I'll begin. So thank you all for sticking around in your busy evenings or afternoons to listen to this presentation. My name is Emily Rochette, and I'm from the Melbourne Graduate School of Education. And today I'm going to be speaking about understanding the complexity of science teachers' lived experience as they navigate to out-of-field areas, which my previous colleague had outlined pretty well in terms of the humanities, I think. So we're back in Australia, and we know that results from PISA 2015 indicated that a substantial portion of teachers in Australian schools are teaching STEM subjects out of field. And the Australian government's advisory body on microeconomic policy and other issues explains the need to address high levels of out-of-field teaching to improve the school workforce. However, the border between in and out-of-field teaching can be really difficult to identify for multidisciplinary subjects. So in Australia, secondary science teachers are expected to teach across biology, chemistry, earth and space sciences, and physics. And here I'd like to make a distinction between out-of-field science teacher and science teacher teaching out-of-field. So an out-of-field science teacher refers to a teacher who doesn't have a specialization in the 4 disciplines of science. These teachers make up roughly 10% of teachers in Australia, science teachers in Australia, I should say. Now, a science teacher teaching out of field includes those teaching science disciplines for which they don't have a specialization. So this chemistry teacher is charged with teaching geoscience, the study of the solid components of the earth and processes acting on them. Worldwide, geoscience has been documented to be largely taught by non-specialist general science teachers. Now, in the state of Victoria, earth science content descriptions and achievement standards from the Australian curriculum are more specific than those from previous curriculum documents. But this doesn't equate to better teaching and learning. In England and Wales, King has reported that 10 years after introducing the earth science component to the national curriculum for science, teachers' content knowledge continued to remain poor. Geoscience is a historical, interpretive science drawing on evidence to understand the structure and processes acting on the earth. However, this may not be apparent to science teachers teaching out of field because geoscientific epistemic practices are distinct from other science disciplines. So both teachers and students of geoscience need to understand the interaction of Earth's biogeochemical systems. They need to be able to apply methodologies and attributes of fieldwork in multifaceted contexts, and develop 3-dimensional spatial thinking abilities and use retrodictive thinking that often draws on large and incomplete data sets that span vast timescales. So some scholars have called into question how teachers who have not had authentic geoscience experiences themselves can provide these learning opportunities for their students. And Creason and Hobbs explain that the school subject will be a simplified form of the discipline according to how curriculum designers see fit to present it to pupils. Yet, what does this mean for schools? Well, the curriculum designers in schools for the enacted curriculum are the teachers. And when they teach out of field, they may not identify the transferable skills from their specialist areas, nor possess the capacity to model and develop students' geoscientific epistemic practices. Worthy of reflection as well is that information technology has one of the highest instances of being taught out of field in Australia, yet science teachers are expected to seamlessly integrate digital technologies into the regular teaching practice. Well, geoscience is a modern science where cutting-edge technology yields evidence about Earth's structure and history. As such, teaching geoscience with technologies could enable Australian teachers to enact policy expectations placed on them, to scaffold students' digital skills for understanding and communicating science in authentic contexts. So what you're seeing on the screen right now is a screenshot of Google Earth, and I can calculate the slope of this volcano, which is a seminal concept in geoscience because taking the slope of a volcano and making observations of the surrounding areas can allow students to discern the different types of volcanoes and their eruption patterns. However, the literature has suggested that teachers' digital technology use sometimes focuses on low-level teacher-centered tasks disconnected from best practice. So Brantley-Dias, Ertmar, and Ottenbreit-Leftvik distinguish between technology integration, increased frequency of digital technology use, and technology-enabled learning, emphasizing the quality of pedagogy when technology is harnessed for inquiry. So the Google Earth example on the last slide was an example of technology-enabled learning. Now, this presentation seeks to contribute to a discussion calling for more research into the nuances of digital technology use in the sub-disciplines of science, and in particular in the out-of-field discipline. So the data collated and analyzed here are drawn from a wider study of 10 secondary science teachers at an inner city government school in Melbourne, Australia. This study aimed to support teachers teaching out of field with digital technologies. And this table summarizes the teaching experience and specialist areas of 4 teachers whose reflections are examined in the presentation. Despite varying years of experience, all participants identified as science teachers teaching geoscience out of field. So to understand the meaning ascribed to individuals' actions, I use the positioning theory to offer a framework to interpret teachers' interview data. Discursive practices are the verbal and nonverbal symbolic exchanges, indicating normative frames through which people think, feel, act, and perceive. And when analyzing discursive practices, positioning theorists focus acute attention to participants' unintentional use of pronouns, phrases, qualifying words, and paraverbals, which are language features that signify the shifts in storylines within and between conversations as participants interpret their own and others' rights and duties. Now, positions indicate power imbalances that are connected to perceptions of agency. When individuals are positioned, they have a limiting repertoire of acts to negotiate the social episode. And individuals claim rights and duties while being positioned and positioning others. So for example, the curriculum documents assign teachers duties to teach across 4 disciplines of science with technology. However, the extent to which teachers accept this positioning depends on their interpretation of the duty and also their personal capacity to assume it. So here we get into the idea of a teacher feeling out of field. The extent to which positions are accepted or rejected are influenced by the history of interactions, signaling plots and storylines. And to unpack teachers' perceptions of what's going on in schools, I draw on Clandon and Connolly's Cover Sacred and Secret Stories. So cover stories are those that are promoted by school administrators to the wider community. Those won't be the focus of this presentation. We're going to focus on sacred stories. These are the theory-driven view of practice that are shared by teachers, policymakers, and theoreticians. And we're also going to be focusing on secret stories about classroom practice that are often shared in the quiet spaces of empty classrooms. These indicate tension between the cover and the sacred stories. So what I'd like to do now is take you through some data as we try to prepare teachers to teach at the geoscience and digital technologies curricular intersection. And I'm going to focus on teachers' use of technology in their specialist areas first. Notably, these reflections have been organized along a continuum from technology integration, increased frequency of technology use, toward technology-enabled learning, so using that technology for those science inquiry skills. Now, Isabel explains how she draws on the textbook, a trusted resource to utilize interactive software produced by publishers. Right away, she positions herself as a chemistry specialist, and despite the abstract nature of the subject, there are even activities modeling the periodic table. However, Isabel struggles to articulate how these activities develop students' science understanding beyond, quote, emphasizing points. As such, a secret story emerges that indicates Isabel may integrate technologies into her lessons rather than utilize them for technology-enabled learning. Now, like Isabel, Olivia was a chemistry specialist, and she required support to utilize digital technologies for inquiry. Here, Olivia is reflecting on her use of data loggers in the classroom. Now, she defers to her right to choose whether or not to use digital technologies, and she positions the data loggers as barriers to technology-enabled learning because she perceives them to compromise her lesson. The whole lesson's wrecked. Olivia's lack of personal history with the data loggers, however, indicates a tension between the sacred and secret stories, where she can see many of her colleagues using data loggers for inquiry, but she does not know how they work themselves. Now, unlike Isabel and Olivia, who reflected on specific digital technologies, Mary assessed her overall use of digital technologies. And she's not sure if she's facilitating them to the potential that they could have the best outcome for the children in terms of promoting higher order thinking in her classroom. When planning with a team of colleagues, Mary was able to explore digital technologies new to her practice, and she seemed confident to manipulate them. But the perceptions about her own ability to facilitate technology use may constrict her capacity to independently incorporate them into her classes to foster technology-enabled learning. So again, another tension between that sacred and secret story. Now, William, a physics specialist, describes how he harnesses the affordances of students' personal devices in physics experiments. All smartphones have accelerometers on them, but the students don't know about this, so you actually have to physically tell them. Using the qualifying word actually, William implies certainty that students are unaware that their mobile phones can act as data loggers. He reflexively positions himself with a professional duty to teach inquiry through the use of mobile phone technology. And here, a sacred story emerges. I draw on students' personal devices to teach for inquiry. As a confident technology user himself, William's empowered to produce these types of lessons, and this sets him apart from Isabel, Olivia, and Mary, who were teaching science in field, but out of field with digital technologies. Now let's switch focus a little bit to better understand the technology these teachers perceived could be used in geoscience. Notably, teachers participating in this study had varying professional histories teaching geoscience, but they were invited to respond to the prompt, digital technologies that could be used in geoscience are. So Olivia explained that before the implementation of the Australian curriculum, geoscience, quote, didn't have much of a place. She didn't position herself as able to respond to the prompt and a secret stories emerging. I'm a science specialist, but I'm not aware of digital technologies or transferable skills that could be used to teach geoscience. Mary was committed to offering students an equitable curriculum. She queried, what gives one area of science more merit than another? Like Olivia, she didn't have a personal history teaching geoscience, yet she explained, I think there's things out there. Do I know what they are? Maybe not. I would say that honestly, I would need to do a bit of research into this. So Mary is drawing on the personal pronoun I to position herself with a professional duty to research digital technologies. A sacred story appears to be emerging. I anticipate sourcing materials to incorporate technology into my out-of-field practice. What that might look like in the classroom, however, would depend on Mary's confidence with the discipline. So Mary also reflected, I find that I need to have almost a bit of a traditionalist approach to begin with, suggesting digital technologies might be integrated rather than used for technology-enabled learning. Now, Isabel did have a recent history teaching with geoscience, and she reflected on her use of the blockbuster video Dante's Peak with her Year 9 class. It's more of entertainment rather than anything else. Although it's got volcanoes and so forth, I don't think that it actually goes into the plate tectonics that much. It was a reward at the end of the year. So Isabel assumes a self-ascribed duty to reward her students, knowing that doing so doesn't reflect on what she perceives to be best practice. For teachers with a strong geoscience content knowledge, this film could be used as a provocation for students to demonstrate their content understanding by evaluating the film's portrayal of science. Yet for Isabel, a secret story emerges. Sometimes I use the technologies without learning intentions. Now, William also had a recent history teaching geoscience. However, unlike Isabel, he endeavored to engage his students in technology-enabled learning. And in this quote, William's explaining how he used a random number generator on a calculator to model reclamation costs and rehabilitation fines as students mined Christmas cake for precious metals. Although William seemed to be unaware of the digital technologies that could be used to collect real-time data, such as Google Earth, he's well known for seeking out and learning how to utilize and adapt to technologies for inquiry, reflecting a sacred story. My digital practices are transferable even when I'm developing a personal history teaching out of field. So of these 4 teachers, William's experiences really seem to set him apart from the others. Unexpectedly, Isabel, Olivia, and Mary seem to be teaching across 2 out-of-field areas. Now, the science inquiry skills strand of the Australian curriculum requires students to utilize digital technologies to achieve a deeper understanding of the science concepts and how scientific thinking applies to these understandings. Isabel, Olivia, and Mary's reflections highlight tension between the sacred and secret stories where the intended use of digital technologies seems to be disconnected from their professional and personal capacity to teach inquiry with them. As such, these teachers required targeted support to teach across 2 out-of-field areas. Now, Hobbs and Schoner explain that the challenge for the out-of-field teacher is to, quote, adapt what they know and can do to new subject areas, and then apprentice themselves into the new specialization. So very similar to these teachers trying to navigate their way across a lava field in Hawaii on bicycles. When supported at their point of need, teachers may reconceptualize their identity and practice. But if teachers are to become effective technology users, they require practical strategies for overcoming barriers and models, exemplifying a range of possibilities for computer use. Now, this presentation drew on data from the wider study that examined first science teachers' existing practices and then worked towards supporting them to teach out of field across 2 areas. The study highlighted the importance of pragmatically supporting teachers such that they explicitly understood what they're professionally held accountable for. So learning activities and resources were offered to teachers that explained geoscience pedagogical content knowledge. These learning activities were sequenced such that both students and teachers' digital inquiry skills were scaffolded along a developmental continuum. In addition, differentiated professional learning experiences were offered to these teachers along with as needed technical support to pump up their ability to use the technologies themselves. And finally, the digital skills that students were expected to develop were included in the assessment, highlighting that inquiry practices are seminal to a student's science experience. And with that, I'd just like to finish there and say thank you so much for listening, and I'm happy to address any questions.